Physical properties of dihydrogen. Dihydrogen is a colorless, odorless, tasteless, and combustible gas. It is lighter than air and is insoluble in water. Click on the play button to see the animation. The chemical behavior of dihydrogen, and for that matter any molecule, is determined to a large extent by bond dissociation enthalpy. The HH bond dissociation enthalpy is the highest for a single bond between two atoms of any element. What inferences would you draw from this fact? It is because of this factor that the dissociation of dihydrogen into its atoms is only 0.081% around 2000 Kelvin, which increases to 95.5% at 5000 Kelvin. Also, it is relatively inert at room temperature due to the high HH bond enthalpy. Thus, the atomic hydrogen is produced at a high temperature in an electric arc or under ultraviolet radiations. Since its orbital is incomplete with 1s1 electronic configuration, it does combine with almost all the elements. It accomplishes reactions by number 1. Loss of only electron to give H plus ion. Number 2. Gain of an electron to form H minus ion. And number 3. Sharing of electrons to form a single covalent bond. The chemistry of dihydrogen can be illustrated by the following reactions. Reaction with halogens. It reacts with halogens X2 to give hydrogen halides HX. The reaction is H2 plus X2 gives 2HX, where X is fluorine, chlorine, bromine, and iodine, while the reaction with fluorine occurs even in dark. With iodine, it requires a catalyst. Reaction with dioxygen. It reacts with dioxygen to form water. The reaction is highly exothermic. It is 2H2 plus O2 in the presence of a catalyst or external heat gives 2H2O in the liquid form. Delta H for this reaction is minus 285.9 kilojoule per mole. Reaction with dinitrogen. With dinitrogen, it forms ammonia. The reaction is 3H2 plus N2 in the presence of iron as catalyst at 673 Kelvin and 200 atm pressure gives 2NH3. Delta H for this reaction is minus 285.9 kilojoule per mole. This is the method for the manufacture of ammonia by the Haber process. Reactions with metals. With many metals, it combines at a high temperature to yield the corresponding hydrides. Click on the button. Reactions with metal ions and metal oxides. It reduces some metal ions in aqueous solution and oxides of metals which are less active than iron into corresponding metals. The reactions are as shown. Reactions with organic compounds. Number 1. Hydrogenation of vegetable oils using nickel as catalyst gives edible fats. Margarine and Vanaspati ghee are the examples. Number 2. Hydroformylation of olefins yields aldehydes which further undergo reduction to give alcohols. The reactions are as shown. Question. Comment on the reactions of dihydrogen with number 1 chlorine, number 2 sodium, and number 3 copper oxide. Solution. Number 1. Dihydrogen reduces chlorine into chloride ion and itself gets oxidized to H plus ion by chlorine to form hydrogen chloride. An electron pair is shared between H and Cl, leading to the formation of a covalent molecule. Number 2. Dihydrogen is reduced by sodium to form sodium hydride. An electron is transferred from sodium to hydrogen, leading to the formation of an ionic compound Na plus H minus. Number 3. Dihydrogen reduces copper oxide to copper in zero oxidation state and itself gets oxidized to H2O, which is a covalent molecule.